Hello Spark fans and welcome back to Advancing Spark. So today we are digging into the world of Databricks SQL once again. That's the whole SQL querying, SQL endpoints, dashboarding side of things that we saw originally as SQL Analytics, now called Databricks SQL, and it's where we go if we want to run lots of BI style querying. And there's two things I want to go and take a look at. Number one is the enhanced query history view. So we've got a much more detailed, much better view of what happened anytime someone runs a query. And even the flat list of SQL queries people have written is a major selling point of Databricks SQL. It's really useful being able to see that. But now the deeper breakdown and the slight execution plan and what we can do from there, there's some really nice things in there. So I just want to take a quick look at that stuff. The other reason that I'm back over on the Databricks SQL side of things today is the release of Spot VMs for Databricks SQL. So we've done previous videos, we've had a look at Spot VMs. That's that whole thing where you can bid on using cheaper VMs. You know what? I want to pay less for my Azure VMs, please. And you get it at a much cheaper cost, but at the risk that someone will come and outbid you and go, no, I'll pay full price. And they take your VM away from you and give it to the person paying full price. So it's cheapness at a risk. Occasionally things will slow down. And that is now possible in Databricks SQL. So we'll take a look at those two things, the new query window and the new Spot VM ability. And when should you use Spot VMs? How do you know whether you should use it? It's easy to see in the interactive clusters, but how do you see that stuff in Databricks SQL? There's a way. So we'll go and have a look at some of the details behind the scenes. If it is your first time around here, don't forget to like and subscribe and all that good stuff. Say hello down in the comments. Let me know how much you're currently using Databricks SQL and if Spot VMs are on the cards for you. If you're like, yes, that's going to save us so much money, then let me know, because it's interesting to see how much people pick it up. Cool. Right. Without further ado, let's go and have a look at Databricks SQL. Okay, so I've got my SQL site. Again, if you've not used it before, you should see it these days. You've got the little drop down in the corner. So even if you're in the normal engineering side of things, slightly more familiar, there we go. The normal Spark window. You can click in here and go, I want to go over to the SQL side of things, and it opens up the SQL persona. And there we can go and see things like SQL endpoints and stuff like that. So I currently have my marketing analytics SQL endpoint up and running. And I can go into my SQL editor and I've got a query. I can just run that query and I can go and have a play around and do stuff like that. I've got this little bit of aggregation in my taxi data. I'm doing some averages, I'm doing some grouping, all that kind of stuff. So I've run some queries, so I should have some history. So the nice thing is over in this query history, we can go and see what's going on. I click on that, I get this big old list. I get this list of here's all the queries people have written on that cluster, on that endpoint. Actually, across any endpoint, I can currently saying just on that endpoint, quite flexible what we can see. You can see that really quick little, I just did a select star, go and give me that query. And I can see I've got some data in there. My face is in the way of some of the information. Go. They can just see things like how many rows were returned, the total time, how much it read, all that kind of stuff. You can see in this case it was cached, and we'll come on to that in a second. I can see this breakdown of optimizing query and pruning files, essentially executing the thing, and then actually result fetching, sending it back to me on my browser, my client, and access via the driver. And we get that nice breakdown. So we know, okay, well, so it was about 50-50, or slightly 50-50 in terms of reading and getting the data versus running the thing. Whereas if I think I just spent so long actually reading it and then a tiny bit of time running it, it's like, well, maybe I can optimize that. Maybe it should be partitioning. Maybe it should be trying to reduce the thing. It allows you to know where you should spend your effort to speed this thing up, which is, again, always appreciated. But that's okay. We've now, hidden off down the bottom. Let's bring this up. We've got this new fancy button. View query profile. And if we click on that, that takes us into essentially a SQL execution plan view. So we can go and see what's happening on that query. In this case, really simple. It's doing a scan of that table and then it's returning it via the driver. Nothing crazy. I'm not expecting to see a lot of stuff there, but there's a nice amount of detail that you're getting in terms of time spent fetching data, size of files read, number of output rows, and then all of the different columns that were returned by that part of the query, by that stage in my Spark plan, what was actually that data frame looking like. To see. Go even further and go, I would like this in verbose mode, please. Just give me all the information you got. Did you hit the cache? How much did you write to cache? How much did you do with the cache? So we can see here it did cache hit size was 30,000, cache hit size uncompressed 36,000. It read it entirely from the cache, which is great, nice and fast. But we can see what it's actually doing as we dig in underneath that. Good. There's some interesting stuff there. As to why it's going from cache. So when did I first run this after we turned it back on? I think it was going to be this one. Go and see. Get this over verbose mode. See what went on. Look at this scan. And there we go. Okay, so this was exactly the same query. And cache hit size 0. It didn't hit the cache. Cache write size 30,000. Now, that's just a SQL query. I didn't tell it to cache. I didn't say go and cache my data. All I had was a query that said select star from that table, and it automatically cached it for me. That leads us to some assumptions. Is it doing delta caching? Does that mean that when I pick my SQL endpoint, which the only thing I've said is make it a small, please, so no config, I've not told it anything, and it's gone and used delta caching, which is super useful and super interesting, but we can check it out. And that's where we get into the digging deeper side of things. So if I grab something that is using things, let's go for the aggregate table. It's probably a little bit more interesting in terms of what it's doing. There we go. So slightly different in terms of the query, slightly different balance in terms of pruning versus execution. It was harder to do execution-wise because it had several stages of aggregation. Makes sense. Look at the query profile. We can see the scan, the hash aggregate, the shuffle, and then the hash aggregate again. So it's going through those different steps. But if I was looking at this in Spark, I'd expect to see something very similar. I'd want to see this thing, or this graph view, which is essentially kind of going through those steps of, well, this is what happened. I started off by reading data. I then did an aggregate. I then did my shuffle. I then did another aggregate. And normally we'd see that in the SQL execution plan inside the Spark UI. Weirdly, it's the other way up. I don't know why it's going up. Why we're going up, not down. It's very confusing. But essentially, in a normal Spark UI SQL execution plan, we'd see that exact same thing. We'd see I'm reading some data, I'm aggregating it, I'm going to shuffle it in a new stage, and then I'm going to do another aggregate. Should be able to see that, because what we've got up here, because this is a Spark job, we've got the open in Spark UI. And that means we can go and take this query and go and have a look and go and say, well, what actually happened? And lo and behold, we've got the exact same thing. This is what we're used to seeing. If you ran this in data engineering mode inside a notebook, hit go, open the Spark UI, you would see this. Go in and we can see all that same detail that we had there. Number of files read, number of rows output, all of that kind of good stuff is in this same execution plan. It's just normally it's kind of hidden away a few steps away inside the Spark UI. So we can it's doing that. It's doing its aggregate inside that stage, doing the exchange, which is just a shuffle. Then doing its secondary aggregate, then it's returning it back through the driver. So it's telling us the same stuff. It's just on the one side, it's made nicer. I can see it in nice mode. It's nice and easy for SQL people. We can say, I don't want to see that in terms of how long you took. I want to see it in terms of rows. I want to see it in terms of, there we go, peak memory. How much memory was it using in these different status? Say 64 meg, 64 meg. Essentially, how much is having to cache, how much is having to juggle across various things. So definitely interesting improvements in terms of having a look at query optimization and what we're doing on the Databricks SQL side, the fact that we have exposure to all of this stuff. So yeah, that's nice. Good. That's one thing. And we're going to use some of that to kind of make some smarter decisions in a second. So the other new thing I promised you was the fact that inside our SQL endpoints now, we have the ability to say, I would like it to use Spot VMs. So I've got my new cluster name, it's going to be my Spotty VM. I did it to be an extra large. I want it to be nice and small. Auto stop, yes please, do it after 20 minutes. Do I want it to scale clusters? Remember, this is scaling whole clusters, driver and workers, not scaling the number of workers. It's different to auto scale in the normal interactive clusters. And then in my advanced options, I've got this. Oh, my Spot instance policy is the new thing that I can now decide. Do I want my Spot instance policy to be cost optimized or reliability optimized? So remember, Spot VMs is essentially in the Azure data center that we've got it in. They have a ton of capacity. They have so many hundreds of thousands of CPUs sitting there waiting to be used. And if they're all being used, Microsoft are happy. If like 20% of them are being used and 80% of their thousands of CPUs are sitting there with doing no processing, Microsoft aren't making money. And it's better for them, for someone to be paying a lower price to be using that spare excess compute than for the CPU to be sitting there idle. And that's what Spot VMs are. Spot VMs are you saying, can I pay you a low price to use a load of compute that would just be sitting there idle otherwise? And Microsoft go, yes, of course you can. Go use them, go nuts. But if demand goes up, if the data center gets really, really busy and people are saying, look, I want my VM and I'm paying full price for it. If you're paying 50% of the price on a Spot VM, you will be evicted from that Spot VM. They'll drag that CPU away and they will give it to someone paying full price. And that's the price that you pay to not pay that price. Yeah, that's the whole point of Spot VMs. Now, normally it doesn't really matter too much in Spark. Because if you think about it, if we've got our driver and we've got 2 workers, and then we've got the whole thing Spark works by those RDDs, those resilient distributed data sets, the resiliency is the key point. If I've got I don't know, maybe I've got 8 tasks in my job on a particular stage, and then that's spread across 2 workers, you do 4, you do 4, I'm nice and happy, there's parallelism. And then one of those workers gets evicted, disappears. That VM disappears from my cluster. And the Spark server goes, okay, well, we'll spin up a new VM and we'll pay full price for it. I'm going to be waiting 2, 3, 4 minutes for that new VM to spin up and take its place in my cluster. Now, during that time, those 4 tasks the original worker had will just be reallocated. If the other worker finishes its task, it'll just start work on those 4 from where it left off. Those tasks are deliberately built to be able to be passed between any of the workers should one of them disappear, hence the resiliency of the RDD. So normally Spot VMs, if I've got a load of different VMs in my workers and one of them disappears because it's been evicted because my Spot VM price went down, I don't care, I'm happy, I'm not paying that much money. So Spot VMs mean occasionally jobs will take longer because it's having to replace a worker, it lost some concurrency, it lost some parallelism, but you weren't paying that much for the service, so you're quite happy. But when you're putting it behind Databricks SQL, and you're saying, hey, look, users, run your dashboards directly on my SQL endpoint, but and explore and play around with the data to your heart's content on my SQL endpoint, and then the endpoint goes dramatically slower occasionally. That's not cool. We don't like that. In those cases, you'd want to pick reliability optimized and pay full price for your VMs. So do you want Spot VMs to be on? Depends on, do you mind if occasionally it goes slow because it happens to be replacing an evicted VM, but you're generally saving a lot of money on your VM costs. That's how we're thinking about things. Now, the decision depends on the size of the cluster size. And that's what's really hard here, because it's like, well, if I've got 10 VMs and one of them gets evicted, so I'm having to deal with 9 VMs, I don't really mind. I've still got a lot of parallelism I can still be serving while I'm replacing it. If I've got 1 VM and my 1 worker gets evicted and I have to wait for it to come back, I can't serve any queries in the time I'm waiting for that VM to come back up. And that's awful, really bad. So it's a really hard decision. Normally, if you're working in Databricks on the engineering side, you can just look at your cluster and decide, actually, you know what? I'm going to choose Spot VMs, but I'm going to have a larger number of smaller workers so I'm protected against eviction of that stuff. Now we can't really decide that because we only have the t-shirt sizes of the VMs to go on. But what we can do is have a look at what that template looks like. So my other cluster, I've got 2x small setup. So marketing analytics is a 2x small cluster. What does that mean? Is 2x small 2 small workers? Is it 4 small workers? Is it 1 gigantic worker? We don't really know looking at this. All we can see from here is how many queries people have run. Is my cluster turned on or not? How many clusters do I have? That's all the information we have. But going that same route we went and going into our query history, jumping into a query that did use Spark and opening up my query profile, and use that link to get into the Spark UI. And yes, I see my SQL execution plan, but I've got all my usual tabs along the top. So what we can do is we can dive into executors. And we can say, what's currently running? Oh, okay. I've got a driver node and I've got 1 worker node. So my 2x small sized SQL endpoint has two machines. One is a driver, one is a worker. That worker has probably 64 gig of memory and it's carving up some to keep for caching and whatnot. And it's got 8 cores. So I know roughly the kind of box I'm talking about. We can go even more detailed and get even more information. So I've got one of those workers. I know I've got one worker. I don't quite know which machine type it is. So if we dive into environment, that gives us all of the Spark settings we could possibly want. I mean, I can see, well, what is this Spark thing? So one, yes, I am using Spot VMs on this cluster. So I can see it is using Spot with fallback. That means fallback means it will replace it with a full price VM should it get evicted from the Spot. So it's not going to be down for that long. You can see the VM size. My cluster node type is a standard E8 v3. So that, very importantly, is a Delta cache enabled cluster type. So that's why it was doing auto caching for me without me telling it to. It was caching it automatically to local SSDs because it's Delta cache enabled. We can check that. If we go into normal Spark and I dive and I try and create a cluster, I can go and have a look at my worker types. And then right down here, we can see under memory optimized Delta cache accelerated clusters, we've got our standard E8 v3. So it is a 64 gig, 8 core box. So I know that my 2x small has one chunky worker. So that gives me a bit more information to make that decision on. If I decide to go ahead and leave that with Spot VMs, occasionally the one and only worker in that cluster will be evicted. And it'll take a couple of minutes before I get a full price worker come back up and then it can continue. Now, in this case, if I was using this to refresh a Power BI model on an hourly or nightly increment, cool, fine. That's going to be nice and cheap. Happy days, just make it run. Make it cheap. I don't care if occasionally my refresh takes 3 minutes longer because it had a fallback in the middle of it. Cool, doesn't matter. It's going to cost me a lot less. If I'm leaving this up and people are expecting to be able to run dashboards on it and use direct query over it or use it to explore the lake, and just occasionally they're going to have to wait 3 minutes while it sits there going, I can't do anything. Maybe that's not a good idea. So say if you're deciding whether or not to go with Spot VMs are fantastic for reducing the underlying cost of the tin that your Spark clusters are running on. Just be aware of the fact it might occasionally disappear. One of the questions I did have people asking on YouTube and LinkedIn going, can you tell if it's currently using Spot VMs? And you can tell if the cluster's set up to do it, but can you tell if that current node has been evicted and come back up as a Spot VM or it's not? I couldn't really find out a good way without just going and having a look directly at the VM itself. So in my Databricks workspace, despite the fact I've set this up as a SQL endpoint and it's doing all that kind of stuff, it's still creating the things in the managed resource group for you. So I can go into my managed resource group. I can see the various different virtual machines I've got in here. I have two because I had 2 clusters turned on. And we can go and dig into the virtual machine and say, right, what are you? What was created here? And in this case, you're right at the bottom. This is indeed an Azure Spot VM. So if you've got that setting saying, yes, it's Azure Spot, then this is a VM that has been configured and set up as a Spot VM. If we go out to one of the other ones, that was the other place we could see it was a E8 v3 as well. We go to another virtual machine. This one is not a Spot. So it's probably the driver. So my driver is not a Spot VM. It's not going to get evicted. I'm going to be happy that it's there. My worker is a Spot VM. That might get evicted. I need to be careful about it. Actually, no. It's a different cluster. It's a different machine I've got turned on. It's fine. It's all the same thing. So yeah, you do have that as a backup. Can you programmatically ping the cluster and say, are any of your nodes currently a Spot VM? I don't think you can. I've not seen a way of you being able to do that. Certainly there's nothing I could see on this main kind of executor screen, which is where I'd expect to see a lot of this information, especially on the fact that SQL endpoints, I think the logging is disabled. Yeah, log viewing is disabled on this cluster. So we can't even get to some of the normal logs that we would have if it was normal straight Spark UI. To be fair, I get the impression that, Databricks don't really want us having a mooch around the Spark UI of the SQL endpoints because it's meant to be easier. You're not meant to need to go and look at all of that stuff and all of the governors and all the machine types and how many workers, because they've tried desperately to say, look, this is super easy. Just spin up an endpoint. If you want it, if you want the risk that occasionally things will be a bit slower, tick this box that says Spot Instance Optimized. That's all you need to think about. Don't worry about it. It's just, if you're trying to make a sensible decision about whether you need that and whether your various different data consumers will accept it, just have a think about how many VMs you've got in that mix, and you can take a peek if you need to. Final thing I wanted to show you. What are we doing for time? Oh, it's a long one again. It's not too bad. Is this channel that we're on. So when we're in SQL endpoints, you don't have the Databricks runtime. You don't have that same decision of saying, I want to be on 10.1, 10.2, 10.3, or what have you. Instead, the only thing you have when you create your SQL endpoint, a little button saying, should it be current or should it be preview in terms of the channel that it's on? Are you on the preview track? Do you want to enable preview features? And what it really means is which Databricks runtime is it using under the hood. Now, I was trying to use some of the new things. So I was trying to use some of the encryption parts and having a play with some of the interesting bits around that. And it wasn't working. And I was like, wait, is it not on 10.3 yet? I go and create a cluster over here. I can go on 10.3, and that's not preview. That's a released GA release. So I want to see 10.3 as my most recent version of it. And I was having a play and going, well, why is that not working? Why can't it see the AES encrypt and decrypt functions? And then digging around back here again in my environment, I can go down, I can scroll around, and I can find a sneaky little thing in here. Go. So that cluster usage tags, the Spark version tells us which Databricks runtime this is currently on. So this is on 10.2. Even though I've ticked that preview flag, it's only 10.2 that the SQL endpoint is currently using. So if you're ever not really sure what that current versus preview flag means and whether or not we're worried about that, have a look in the Spark UI. It's where you can get the gospel truth about what's happening on that endpoint. 10.2 is the current version of the SQL endpoint, despite the fact I've hit that preview flag. Doesn't matter, it's still using 10.2. So at some point, I'm sure we'll see a little message go out going, hey, anyone spinning up a SQL endpoint from now on, 10.3 is your default. Either the current or the preview, we'll see. And then suddenly all that stuff will work the next time we start that cluster up. But just don't forget, if you've ever got any questions about that, you're not sure about what it is actually doing, because it's been made so nice and so user-friendly, it doesn't have that much details there, you can always get down to the low, dirty details behind the scenes. But now, don't take it away, please. Cool. All right, so that's everything I wanted to go through today. So don't forget, if you are using Databricks SQL and you want to reduce costs, think about making it cost optimized on your Spot VMs. Just be very careful that you don't turn it on when users are expecting super lightning fast queries, because it might occasionally let them down. If you're doing overnight refreshes of models, absolutely turn Spot VMs on and it'll make things a lot cheaper. Should be good, unless you pick the busiest time of day to do your model refreshes. And yeah, take a look at the query history, because it just got a load better. It's got loads more details. It gives you the couple of steps about how to understand that query. I would almost say it's actually a really good place to start learning how to troubleshoot Spark queries, because it gives you that kind of simplified view of the different steps that Spark goes through, and it relates back to what you actually see inside the Spark UI when you're doing some deeper performance tuning anyway. So loads and loads of useful stuff in there. Go nuts, have a play, go look at some stuff. As promised, I will be doing some more videos soon. We've got loads of new things that have been released. We had the announcement that we now finally have the ability to merge inside Delta Live tables. Yes, there's a video coming on that. Calm yourselves down. I do want to get the encrypt videos done. So being able to encrypt and decrypt on the fly based on user permissions, kind of like row level security, but not removing the rows, just decrypting, is super useful and is such a known pattern out in the warehousing world. And I'll be doing a video about that over the next week or so. So yeah, loads of interesting stuff. As always, don't forget to like and subscribe. Let me know down in the comments if you're going to use Spot VMs. Have you played with them? Are you saving money? It's always good to hear how you guys are doing. All right, till next time. Cheers.